In a breakthrough for astronomers, the James Webb Space Telescope, JWST, has taken its first direct image of a planet outside our solar system. Called HIP 65426b, the Jupiter-like planet orbits a dwarf star about 385 light-years from Earth. Its imaging could help scientists find many smaller types of exoplanets. One of the hardest ways possible to find an exoplanet, the success of JWST's first attempt at directly imaging comes just days after JWST detected carbon dioxide around another exoplanet. The images look even better than the simulated images we produced many years ago, said Sasha Hinkley, associate. HIP 65426b is 6 to 12 times the mass of Jupiter. According to NASA, it takes 637 Earth years to orbit its star from 92 astronomical units. That's twice as far as Pluto does from our Sun. It was first discovered in July 2017 by scientists using the Spectro-Polarimetric high-contrast exoplanet research instrument, SPHERE, a planet finder at the European Southern Observatory's Very Large Telescope, VLT, in Chile. The discoverers suggested it has a warm, dusty atmosphere. Astronomers used two of JWST's key instruments to capture the exoplanet, its near-infrared camera, NIRCam, and its mid-infrared instrument, MIRI. The glare from a star on the dust around it can make it impossible to detect the faint reflected light from exoplanets around it. Cue a coronagraph, a black disk that is positioned precisely in front of a star to block out its light. We picked this star as we knew it had a well-established planet that would be right for direct imaging and would therefore be an outstanding first target to test the JWST coronagraphs, said Hink. NIRCam's task is to detect light from the earliest stars and galaxies. It's equipped not only with various filters to create observations at different wavelengths, but also with a coronagraph for blocking the light from a star. That's exactly what the researchers used to find HIP 65426b around its host star. The MIRI instrument is a camera and a spectrograph that sees light in the mid-infrared region of the electromagnetic spectrum. JWST appears to be about 10 times more precise than predicted, according to the authors, for whom precision was everything in directly imaging HIP 65426b. The planet could only be located by first observing the exact structure and intensity of residual starlight around the coronagraph and then subtracting it away to leave behind the planet.